I printed this simple grid to help you guys start seeing things in 3D space as opposed to seeing them in flat 2D space. It is actually a difficult transition to make, but once you make it, it's going to make a huge difference in not just how you draw, but how you see things. One of the major things that we have to train ourselves to do is to see and interpret what we're seeing, which is why one of the things where we're going to, I've mentioned, you're not just drawing from life. You're not going to just draw what you see. You have to interpret what you see so that you understand what's going on. So you can not just copy it like a copy machine. If you're just copying life, that's not doing you any good. You want to make sure that you understand it so you can turn around and you can draw it on your own without having to see it and still be able to draw decently. So we have our 2D grid here, and I drew the equal size squares just to help you guys see what's going on. So my first big piece of advice is draw from the ground up. It's going to help you use your space more efficiently. You'll make sure things aren't going to intersect, and things will share the same space. For example, if you were to start to draw your box and then draw the cylinder from the top of it, it's not going to solidly line up with the box. And it's going to seem, disconnected and floaty. It's not going to fit. And same thing goes with your sphere. As you're drawing, these spheres, it's difficult to make it distinct from a sphere and a circle. But as you learn these things, you will be able to without having to rely on shading. So intersecting is a big deal. A lot of people are actually doing that most of the time. Think of it in terms of a bounding box. These each have the same bounding box. And I line them up roughly centered. That's why these extra lines are on there, to keep them centered. And you can see the box fills its bounding box. So nothing can pass the bounding box at all, or else it'll be intersecting. The cylinder, because its base is a circle, doesn't fill the entire thing. It touches on the edge, and this is, the shapes aren't perfectly lined up with the paper, so ignore it. Just pretend it's touching at the edges. It's touching at the edges, but then these little cuts here, something can overlap that, but if it does, it's starting to crowd things too much. And it's difficult to tell how much space is between it. So you want to keep things outside of this bounding box. The same thing goes with your sphere. It's got the same circle bounding floor space as the cylinder does, but the square, it comes from the square, and that's, you want to do the same thing. And this is a little bit of distortion, why it doesn't look like it's completely centered, but it is. And it looks like the contact space is further back on the sphere than it is on the cylinder, because it is. The sphere only, and I cut the bottom off of this to make it actually stay still, so you can see that contact point really nice and clear without it destroying the shape of the sphere. It's touching very close to the middle, and this one is touching at the edge, so you have about this much space between where this touches and where this touches on the surface, on the ground. So these are all things you have to consider to make sure things are not going to intersect. You have to consider also, not just the surface, and these are the surfaces and the surface volume, but the surface space, but you also have to consider internal volume. This bowl here, let's try and line that up. This bowl here has all of this space empty inside it, so it's very easy to see. And it's a little flattish on the side, but let's just pretend it was a complete sphere that was cut in half. Now this sphere doesn't fill up all that space. When you draw this sphere inside of this spherical bowl, we still have to be able to tell that they are two different objects. and maybe a little difficult to see. So add a little light. There we go. When you look in here, you can see that this sphere doesn't follow the same shape as this sphere. They're going to have the same touching point, but that's about it. This one's going to come out. It's because it's got a larger diameter. It's going to come out further, and so they're not going to share the same line, just that same one contact point. You're going to see the visual difference when you draw your sphere inside of a sphere. It's not going to just be, you know, an oval with a circle in it, which is what most people tend to draw when they put, like say this looks like an orange in a bowl. If you're going to put an orange in a bowl, it's not going to just look like a circle that's sitting and overlapping an oval. These things are really important to make the distinction between kind of throwing down symbols that represent what stuff is supposed to be and actually drawing what you're trying to draw. Especially, say, a lot of us want to do comics. We like to do, illustrations. Especially if you want to do comics, characters are going to interact with these things. They have to be solid. And this is why, I'm harping on this stuff so much. Things really need to be solid. They need to be their own individual objects. Everything has internal thickness. This bowl is very thin, but it's still 3 different surfaces: the cut across, the front surface, and that back surface in there. There is volume in between that. Just like there's volume, this empty volume here, and this has volume inside of it. And where they're touching, but they're still not sharing, they're not touching exactly the same point. One is on top of the other. So there is minute space in between them. So if you could see the contact point, which when we talked about drawing flat things, like you can see this paper, it's not exactly straight, so you can see the space very clearly. You have to make sure things like that, because that's how it exists in real life. You can, with the heavier line, it denotes the shadow of the space in between, which is, if you review, I believe that was week 2, drawing flat objects, that's why I talked about that when I did, because it comes into everything that's going to come and wrap up and come into play. So the technical part of seeing stuff in 3D, because this is, visual, you can see it working in action. Now the mathematic part, which is cut off a little bit, so let's move this over a little. All right. So there's these things. If you took algebra, you're familiar with axes. So we have, in 2D space, our y goes up and down, and our x goes side to side. In 3D space, we add a z, which goes back into space, and it comes forward into space. I'm actually holding this pencil perpendicular, and it's actually continuing that line. So it is 90 degree edge between the corner with the x, the y, and the z. They're all exactly 90 degrees. That's important, because when you we're not working, if you're drawing flat on the paper, you're going to make this up and this to the side. But when you're trying to draw in 3D, you have to consider that the paper is laying, your surface is laying flat on the ground, so can't really see it. This becomes your y. So this is now your y. Your x is still side to side, and your z goes back into space. And now you can see the 90 degrees pretty clear here. That's what you're trying to achieve. You want to make sure back and to the side is your flat surface, and then up is up. That makes it's very difficult to start seeing things like that. But it's, like I said before, it's going to make a huge difference. And I'm kind of keeping this there so you could soak it in. Let's actually use our sphere, because, you know, like I said, the circle and the sphere. In 2D space, up and down, that's a circle. That this makes a circle up and down. In 3D space, it is a sphere, because you're considering what goes back into space, and your up depends on that, rather than trying to draw things going back into space depending on your up and down. And I'm actually going to show you an example of that in a minute.